The same exact sort of piece of paper, so to speak, that we left off on. Today is 11/14. It's the 14th of November. And we left our brave chemistry heroes having talked about the first two main energy levels. And we said that on every energy level, there's a little tiny spherical orbital. We've got a picture of our little tiny spherical orbital. It's adorable. Everybody thinks it's adorable. I'll take a picture of it to prove how adorable it is. There. Isn't it cute? And because it's a sphere, there's only one way to line it up. So if you remember, the main energy level, this n equals, is just the number of the level we're on. 1, 2, 3, 4, 5, 6. It's crazy. The sub-level can be thought of as the shape of the orbital that we're dealing with, orbital or orbitals. And we said every single energy level has an s orbital. No matter how high up we go, they all have an s orbital. And those don't look like very good s's. Let me fix them. I'll copy this one because that's a good s. Undo. Sorry. Nope. Cancel. Okay, so every level, no matter how high we go, has an S. And starting on the second main energy level, there's a second shape. And that second shape, we said, well, people describe it as two drumsticks shoved together, a dumbbell, whatever you want to call it. Basically, it looks like that. And when we get to the second, everything after the second energy level has these orbitals, these p orbitals. I'm just not having a good day with cut and paste. It's not my day. Copy, paste. So once we have a shape of orbital, every level above that has that shape. So everything from 2 and up has p orbitals. Now, we said that the third sort of address component for our electrons was the orientation or direction that the orbital is arranged in. And it's the magnetic quantum number. It's nm, rather. Nobody cares that you know that. I don't care. Unless you're going into particle physics, nobody else cares either. Every single different way that we can arrange that orbital, there will be an orbital arranged that way. So for the p orbitals, there are 3. There's one on the x-axis, one on the y-axis, and one on the z-axis. The z-axis comes out at you in space. So we have one s orbital because there's only one way to arrange a beach ball. Doesn't matter how you arrange it, it looks the same. We have 3 p orbitals. So how many total orbitals? Let's start with the first main energy level. How many total orbitals are there? 1. How many total orbitals are there on the second main energy level? Count these. How many? 4? 4? Okay. And in each of them, you have electrons arranged up and down. Great. Well, let's look at the third main energy level. N equals what? 3! It's not a trick question. So on the third main energy level, we add another shape. And that orbital type or shape is called a d orbital. It looks pretty weird, admittedly. And every energy level after, every single energy level after the third one has d orbitals, because that's just the way it works. So, d orbitals are a little tough. Okay, so for d, it's a little hard to sort of visualize or wrap your head around, so hopefully this helps. Don't even try to name these as like the x, the y, and the z, because it's more complicated than that, because you have arms and legs, actually just orbital chunks, going along multiple axes at once. So we don't typically name these. With the p's, we can say the px orbital, the py orbital, the pz orbital. With these, we just call them D, 1, 2, 3, 4, and 5. And that fifth one is this real weirdo. I like to call it the double drumstick donut. So imagine 2 chicken drumsticks with their little tiny ends shoved into a donut in the middle. That's what it looks like. I'm hungry. We have 5 d orbitals is the point. So drawing them is a little bit challenging. So for the d's, we very often draw them like this. 1, 2, let's see, 3, 4, 5. Whew, that was ugly. And we don't even try to name, we don't even try, like I said, to actually assign axis names. If you can draw something that looks a little bit like them, we'll be happy with that. But the point is there are 5 d orbitals. And just like we've seen with the S's and the P's, once you've got them, shrink that a little bit. Oh, good enough. So we have 5 of those. So how many orbitals do we have total here on the third main energy level? We just added 5. We had 4 before. 9. So 9 total orbitals. And inside each of those orbitals, there are 2 electrons, and they have an address of up and down. So now, I'm going to shrink this to get it out of the way. So we had 1 orbital on the first, then we have 4, then we have 9. Well, when we get up to the fourth main energy level, this would be n equals what? N equals 4. And we have S's, we have P's, we have D's, and we have something else. S, P, D, and now we have F orbitals. And I'm not going to try to draw an F orbital. So F orbitals are too weird to even draw. I will show you an image of what they look like. Not right now. But the thing to remember is that for this weird, freaky, I mean, like literally, something kind of like that would not be an injustice to the F orbital. It's strange. It's got lots of arms and legs going everywhere, not to mention heads, donuts, duck bills, whatever you want to call it. It's crazy. The point is, there are 7 of them. So there are 7 different ways to orient this, what I will politely call a freak show, around origin. F6, F7. So we add those 7, copy, paste, to the 9 we already had. How many orbitals total do we have on the fourth main energy level? 16. Huh, that's interesting. When we get up to n equals 5, do you think we add an orbital shape? Yeah, we do. So we have SPF, SPDF, and we now add, this is the one nobody ever talks about, G. We add G orbitals. Not even going to try. No way. Not going to do it. And guess how many ways there are to orient G's. You might guess this if you're seeing a mathematical pattern thus far. So we had 1 way to orient S's, 3 ways to orient P's, 5 ways to orient F's, 7 ways to orient F's, 9. There are 9 G orbitals, and I'm not drawing the letter 9, G 9 times. Plus all of this craziness from the previous levels. Copy, paste, Guess how many orbitals, oh, and on each of those orbitals are 2 electrons up and down. Guess how many orbitals we have on the 5th main energy level? Actual orbital. It's 25. Lauren, you seem to have arrived at that number without counting. How did you do that?
The energy level squared.
Aha. Yeah. So there are a couple mathematical patterns here, and you picked out the first one. Well, maybe not the first one. Okay, so in terms of the number of orbital shapes that we have, what's the pattern? On the first main energy level, how many shapes do we have? 1. On the second main energy level, how many shapes do we have? 2. On the third main energy level, how many shapes do we have? 3. What's the pattern, folks? It's equal to n. So the number of shapes we have is equal to n. Now, Lauren picked up the second pattern, which is that the total number of orbitals is equal to n squared. Cool. Each of those orbitals can hold 2 electrons. Guess how many electrons can fit on any main energy level? We'll come to that. I'll just let that sort of percolate for a little bit. Okay, so let's look real quickly at a picture of these energy levels. So we have S's, P's, D's, and then we have the F. They don't even try to show anything beyond F, but it is the G. I'll try to find a picture. Hold on. So we've learned all this sort of addressing rules for electrons. Now we have to actually learn how to write the electron configuration of an atom. So we know what the orbitals are where electrons can live. And there are very good reasons for writing electron configurations. I said earlier, we had kind of covered the big stuff. Well, let's address this first. An orbital can hold 2 electrons. Doesn't matter what energy level it's on, doesn't matter what shape it is. S, P, D, F, G holds 2 electrons. There is no orbital that can hold more than 2 electrons. The maximum number of electrons allowed in an orbital is 2. All orbitals hold 2 electrons, or can hold up to 2. How many electrons can a single orbital hold? 2. 2. And I will ask you this question on a test, and somebody will get it wrong. I guarantee you. How many electrons are capable of being held in the px orbital on the 5th main energy level? And the answer is 2. 2. No matter what the orbital is. This is the thing that a couple of you picked up early. This is just the math patterns for this. Main energy level has 1 shape, 1 total orbital, 2 electrons. Main energy level 2 has 2 shapes, 4 total orbitals, 10 total electrons. 3 has 3 shapes, 9 orbitals, 18 electrons. 4 shapes, how many orbitals? How many total orbitals? 16. How many electrons would that be? If every orbital can hold 2, 32. So for n equals 5, how many shapes? 5. How many orbitals? How many electrons? 50. So the pattern, because we can make this really clear, number of shapes equals n. And this is sometimes called sublevels. So how many sublevels are on a main energy level is equal to the main energy level's number. So the number of shapes or the number of sublevels. Number of orbitals equals, it's the general mathematical rule. For n equals 1, it's 1. For n equals 2, it's 4. For n equals 3, it's 9. N squared. And the number of electrons, since every orbital can hold 2 electrons, what's the total number of electrons on any main energy level? 2, what? 2n squared. That's a handy little rule. Because what it means is that I can say, okay, quick, how many electrons can be held on the third main energy level? And you go, 18. Now, do you remember from physical science, you probably did this whole, this whole thing where you had to sort of memorize the energy levels and what was on them, and you said, well, on the first main energy level we can hold 2 electrons. On the second main energy level we can hold 8 electrons, 2, 3, 4, 5, 6, 7, 8. And on the third we can hold 18, and you never really knew why. This is why. Because there are an increasing number of orbitals as you go up in energy. I'm actually going to assign some homework problems and have you get started on those, because I'm going to give you a FIP quiz tomorrow over just orbital shapes and orbital numbers and electron numbers. And I don't want to start electron configurations before we do that. Okay, this is the Chapter 4 review, page 118, 11, 13, 15, and 17, so you can go ahead and get started on those.